Dear students, I am Mahesh Javalkar of Maratha Mandal Polytechnic, and today I am posting my 10th video on DCT questions on the subject BEEE, that is Basic Electrical and Electronics Engineering. Okay. So we'll start with the first question. Question number 181. The back EMF in a DC motor. Okay. The back EMF in a DC motor, that is the EMF which is induced, and that is back EMF, what you get, the voltage that will oppose the applied voltage or aids the applied voltage or aids the armature current or none of the above. Okay. So whenever we have a back EMF in a DC motor, now according to Lenz's law, it's a polarity, okay, will oppose the very cause producing it. Okay. That means the option A, that is opposes the applied voltage, will be the right option over here. So opposes the applied voltage. The back EMF in a DC motor opposes the applied voltage. Okay. Then we'll go to the next question. The motor equation is given by which equation in the options? Okay. So the motor equation is always the voltage is equal to back EMF along with, okay, the voltage produced in the windings of armature, that is IA into RA, that is armature current into resistance of the armature. Okay, so V is equal to EB plus IARA. That will be the right equation for the motor. Okay, so option B is the right answer over here. V is equal to a back EMF plus armature current multiplied by resistance of the armature. Clear? So then we'll go for the next question. Question number 183. The speed of a DC motor can be varied by varying what? Options are field current, applied voltage, resistance in series with armature, or any of the above. Okay. We can vary the speed of the motor by varying the field current IF. We can vary the speed motor by applied voltage. Okay. And we can also vary by varying resistance in series with armature. That will also give a change in the voltage. Okay. So any of the above will be the right answer in this question. The speed of a DC motor can be varied by varying any of the above. Okay. Then we'll go to the next question. In a DC motor, the conditions for maximum power is, okay. The options are supply voltage is equal to half into back EMF, supply voltage is equal to square root into back EMF, then back EMF is equal to 2 into supply voltage, and back EMF is equal to half into supply voltage. Okay. Now, the condition for maximum power is back EMF is equal to half into supply voltage. That is, it should be half of the supply voltage. The back EMF which is produced, it should be half of the supply voltage. So option D will be the right answer here. So according to theory, you can see that the gross mechanical power developed by a motor is power is equal to voltage into armature current minus armature current square into RA. Okay. So differentiating both sides with respect to IA, that is armature current, and equating the result to 0, we get the following equations. So a PM is equal to VA minus IA square RA. Then if you differentiate with respect to IA PM, so you will get IARA is equal to V upon 2. Okay. So that means uh, as V is equal to EB plus IARA, IARA is equal to V by 2. Okay, then therefore EB should be equal to V by 2. Clear? So here V by 2 will be the a condition of the magnitude of the back EMF. That is, back EMF is equal to applied voltage upon 2, that is half of the applied voltage, to give maximum efficiency. Thus, a maximum efficiency of a DC motor occurs when back EMF is equal to half the applied voltage. So option D, what we had said earlier, is the right answer. Back EMF is equal to half into supply voltage, or half of the supply voltage should be the magnitude of the back EMF, so that DC motor gives you maximum power. Okay. Then we'll go to the next question. Question number 185. If conditions for maximum power for a DC motor are established, the efficiency of the motor will be what? 100% or 90 to 95% or 81% or less than 50%. Okay. So the conditions for maximum power for a DC motor are established, then the efficiency motor will be less than 50%. Okay. That is, the gross mechanical power developed by a motor is maximum, okay, is maximum when back EMF is equal to half the applied voltage. This condition is, however, not realized in practice. Practically, it is not realized because in that case, current would be much beyond the normal current of the motor. Okay. Moreover, half the input would be wasted in the form of heat and taking other losses. This is the important statement. Half the input will be wasted in the form of heat and taking other losses into consideration. The motor efficiency will be well below 50%. Okay, that means for this question, it is option D only, less than 50%. So, if conditions for maximum power for a DC motor are established, the efficiency of the motor will be less than 50%. Okay, then we'll go to the next question. Question number 186. When the speed of a DC motor increases its armature current, what will happen to the armature current? Okay, the armature current decreases. So here the option is B, option B, or decreases, and the theory for that is the armature current IA is given as applied voltage minus back EMF. Applied voltage minus back EMF, that is V minus EB upon armature resistance. Okay. Now, if the speed of the DC motor increases, then the back EMF EB also increases. If the EB increases, then V minus EB will become less. V minus EB upon RA, that is armature current, will become less. Okay. That means armature current will decrease, IA will decrease. Okay. So option will be B, decreases. When the speed of a DC motor increases, its armature current decreases. Clear? And now we'll go to the next question. Question number 187. The speed of a DC motor is, okay. Option A is always constant. Option B is directly proportional to back EMF. Option C is directly proportional to flux. And option D is inversely proportional to the product of back EMF and flux. Okay. Now in this, a straight answer is directly proportional to back EMF. Now the theory for that is the EMF equation of a DC motor is given as E is equal to Np phi Z upon 60A, where N is the speed of rotation in revolutions per minute, P is equal to number of poles, A is equal to number of parallel paths, Z is equal to total number of conductors in armature. Okay. Then if you are having speed of rotation, N is equal to 60A upon PZ into E upon phi, then N is equal to E upon K phi, where K is equal to PZ upon 60A is a constant. Hence, speed of a DC motor is directly proportional to EMF of rotation, that is E, okay, and inversely proportional to the flux per pole. So if you want a directly proportional, so it is directly proportional to the EMF. So here option B will be the right answer. The speed of DC motor is directly proportional to back EMF. Then we'll go to the next question. Question number 188. The armature of DC generator is laminated too. Okay. Now, whenever we laminate armature winding or transformer winding or any type of winding in any such electromagnetic mutual induction concepts, then it is to reduce the eddy current loss only. So always remember that whenever something is laminated in mutual inductions, okay, that means it is going to reduce the eddy current loss. That is option C will be the right answer over here. So here you can see the theory. Eddy current is the form of power loss and magnetic loss. Okay. The eddy current loss produce heat and decrease motor efficiency. So these eddy current losses are directly proportional to the area of the armature or more precisely the path of the motion. With laminated armature, eddy current losses are reduced to very less. This is the reason why the armature is laminated. Okay. So here option C, that is to reduce eddy current loss, is the right answer. Then we'll go to the next question. Question number 189. The commutator segments are connected to the armature conductor by means of what? Copper lugs, insulation pads, resistant wires, or bracing. So it is option A, which is called as a copper lugs. Okay. Now these a copper lug or a copper cable lugs provide the electrical connection between the power source to other cables. They are connected to other power electrical equipment such as fuse blocks, starter, etc. Copper lugs are highly conductive and can carry high current. Therefore, a commutator segment is connected to armature conductor by means of copper lugs as shown in the figure. Okay. So here the option will be copper lugs. Okay. So option A, copper lugs. Then we'll go to the next question. Question number 190. The bearing used to support the rotor shafts are generally what? Okay. So these bearings should not have friction. They should not produce heat. They should not produce loss. So that means option A, that is ball bearing, will be the answer for this. The bearing used to support the rotor shaft which is going to rotate, are generally ball bearings. Okay. So option A. So here we can see the reasoning. Generators use coils of wires which rotate through a magnetic field to create voltage, which pushes the current through the wires, thus creating heat. Bearing are used to reduce frictionless losses, ensure smooth running of the rotor. Therefore, ball bearing is used in DC generator to support rotor shaft. Okay. Then we'll go to the next question. This is ball bearing was the answer here. Next question is 191. The material for a commutator brushes is generally of what? A mica, a cast iron, a copper, or a carbon. It is carbon. Okay. So here the material used for commutator brushes is generally a carbon. Okay. Now a commutator is a moving part of a rotary electrical switch in certain types of electric motors and electrical generators that periodically reverses the current direction between the rotor and the external circuit. So two or more electrical contacts called brushes made of a soft conductive material like carbon is is put over there so that this contact is done properly and the part which is moving can move without any loss. Okay. So here the answer will be carbon. The material for commutator brushes is generally carbon. Okay. Then we'll go to the next question. Question number 192. A relay is used to as you all know that a relay is a make or break circuit. Okay. So it is used to, option A is break the fault current, sense the fault and direct to trip the circuit breaker, all of this. So out of this, option C is the right one. It should sense the fault and it should direct to trip the circuit breaker. Okay. So it is a make or break circuit. So it has to sense the fault and direct to trip the circuit breaker. Okay. Then option C is the right answer over here. Then we'll go to the next question. Question number 193. Relay gets its operating energy from what? Transformer, alternator, overhead lines, current transformer, or potential transformer. So the option here is D, current transformer or potential transformer. CTPT. CTPT are going to give energy for operating the relays. Okay. So here option D will be the right answer. CTPT. Then we'll go to the next question. Question number 194. A protective relays can be designed to respond to. Option A is light intensity. Option B is temperature. Option C is resistance, reactance, or impedance. Option D is all of the above. Okay. Now a relay can be activated by any of the physical parameter. Okay. So a parameter can of light, a parameter like temperature, a parameter like resistance, reactance, or impedance. All these can be used to activate a relay. Okay, that means the option D will be the right answer here. D, all of the above. Okay, then we'll go to the next question. The EMF of a dry cell is about how many volts? So it is a general question, and we can see always which are manufactured and available in the market, that the EMF of a dry cell is about 1.5 volts. Okay, so option D will be the right answer here, 1.5 volts. Okay, the EMF of a dry cell is about 1.5 volt. Then we'll go to the next question. In a cell, the a current flows in outer circuit from option A says positive terminal to negative terminal and electrons from negative terminal to positive terminal. This is the right statement. Option B says positive terminal to negative terminal and electrons from positive to negative. This is wrong. Then option C says negative terminal to positive terminal. This is wrong. And option D says negative terminal to positive terminal. This is also wrong. So in a cell, the current flows from positive terminal to negative terminal in the outer circuit. Okay. And electrons will obviously flow from negative terminal to positive terminal. Clear? So option A will be the right answer here. Okay. Option A is the right answer for this question. Then we'll go to the next question. Question number 197. The capacity of a lead acid cell does not depend on what? Okay. Its temperature, rate of discharge, rate of charge, or all of them. Obviously, the capacity of a lead acid cell does not depend on rate of charge. Charging is not going to give you the capacity. Okay. So rate of charge will be the right answer here. So option C is the right answer here. The capacity of a lead acid cell does not depend on its rate of charge. Then we'll go to the next question. Question number 198. When a lead acid battery is in fully charged condition, the color of its positive plate becomes brown or dark gray or dark brown or none of them. Okay. So whenever it is fully charged, the color of the positive plate becomes dark brown. So option C will be the right answer here. Dark brown. Okay. Then we'll go to the next question. Question number 199. The capacity of a battery is expressed in terms of, okay, so options are ampere, volt hour, ampere hour, or volt ampere hour. Okay, so it is option C, which is called as ampere hour. So here option C, ampere hour, is the unit in which the capacity of a battery is expressed. Okay, then we'll go to the next question. Question number 200. Cell is a device. Okay, is a device which converts what? Chemical energy into electrical energy, or electrical energy into light energy, or electrical energy into a magnetic energy, or none of this. Obviously, cell is a device which is made up of chemicals. So it is going to convert chemical energy into electrical energy. So option A will be the right answer. This is a basic definition of cell. It is a device which converts chemical energy into electrical energy. And many cells together will form a battery. Okay. So here option A will be the right answer. Cell is a device which converts chemical energy into electrical energy. Okay, students, these were the another 20 questions on BEE subject, which will be useful for you. Thank you very much.